Good morning, children. Today it is my lecture 17 under gravitation. Hope in the last class you have learnt the one total energy of the satellite, right? And we have learnt the expression for total energy of the satellite. And I said in this class I will be explaining the remaining two satellites. Okay. So before going to that, I just want to give one very important graph regarding total energy which you come across in any of the competitive exams. So let me just highlight you, only by knowing the formula you can also represent in the graph, or you can also identify the graph by just looking to the graph. You can say how you can explain kinetic energy, potential energy and total energy. One slide graph I will tell you for regarding for the one objective type questions. Okay. So please remember, for the one total energy of the satellite, total energy of the satellite total energy of the satellite. Okay. For this I just give regarding total energy, you already know the sum of kinetic energy and potential energy is called total energy, right? For this I just write only the formulas. So using that we can draw the graph. First let me write the kinetic energy. And you know kinetic energy is always positive. So for kinetic energy we have the formula, that is G capital M small m divided by 2m, because you know half mv square. Kinetic energy itself is half mv square. After substituting that we get this relation, that is nothing but that is 2 and that is G capital M into m divided by 2r, right? So regarding potential energy, you know the expression for potential energy, and potential energy is always negative. So potential energy is always negative means again you have the expression for potential energy where it is capital G, that is minus capital G capital M small m divided by r. Okay. What is total energy expression? The total energy is again negative. It is nothing but total energy is equal to, that is minus capital G capital M small m divided by, that is 2r. So these are the three expressions you come across for the one kinetic energy, potential energy and total energy. Now using this I just draw the graph, a graph energy versus distance. A graph is plotted energy versus distance, So here for your reference I write distance is represented by r, energy I represent by E. So I represent energy by E. In that we come across kinetic energy, potential energy and total energy. So here graph is plotted energy versus distance means, you know when you draw the graph you always draw the one vertical line represents y axis, this represents the x axis. But remember I represent this y axis represents energy, this is energy. This itself is origin, you know, and this represents, the x axis represents a distance. X axis represents distance represented by r. So this energy is represented by symbol E, it is, right? This is E, distance is r. Okay. Now by just looking to this graph, here remember capital G is a constant, m is mass of the earth where it is also constant, and this will be this mass of the one object remains also constant. So, only the one 2 is also a number, it is a constant, the only variable is in the one distance r, energy versus distance. Okay. So, now by just looking this, we will select the one graph. Remember in your school days you have learnt the graph in which there are 4 quadrants, first quadrant, second quadrant, third quadrant, fourth quadrant. But you already know where first quadrant represents, here this is x axis, right, this x axis and this is y axis, you know, and if it is the x axis is positive, y axis is positive, means you come across this is plus plus, right, and this is for second quadrant, this is first quadrant it is, right, this will be second quadrant, where it is this will be minus. So, here x axis is minus and y axis is plus. So, this is second quadrant. This is minus, x axis is minus, y axis is minus. So, you are representing this as this is minus x axis, this is minus y axis, this is plus y, this is plus x. Okay. Here this represents, this is minus, right. This is said to be called as third quadrant. What is fourth quadrant? Here this is plus, this is minus. So, x axis will be plus, y axis is minus, plus minus. This is fourth quadrant, right. You know these things. In your school days you have learnt the graph. So, there are 4 quadrants. So, if it is both x and y are positive, first quadrant. If x is negative and y axis is positive, second quadrant. This is third quadrant where both x and y are negative. Fourth quadrant where the x axis is positive, y axis is negative. You are selecting this. Okay. Now, using this, remember when you draw this graph, you are only using first and fourth quadrant. You are using first and fourth quadrant. So, here in this case, the one first and fourth quadrant means only this and this. You are not using third and second and third. Okay. Now, using this, if you observe kinetic energy is always positive. So, distance is positive, energy is positive means you get kinetic energy is positive. So, at that time, depending on this condition where you are observing the one graph like this, you can say the graph is like this. This is kinetic energy. Okay, this is kinetic energy at this position. And what about the potential energy and the total energy? Both are negative. So, both are negative means here you can say the distance is nothing but it is nothing but you come across under this one x axis, energy is under the one y axis. So, energy versus distance you are writing, distance will be always positive, but energy that is will be positive or negative. Since kinetic energy is positive, so we have written the first quadrant, but here these two are negative. So, energy is negative means here we are using y axis, energy is y axis and distance is x axis. So, you can write now here in this case you select these two now. Here this is gmm by r, this is gmm by 2r. So, it is half of this. So, first let me write this is potential energy. This is nothing but the one potential energy. But remember this is also the one called as the total energy is also negative, but remember it is half of that. So, when you say it is half of that means you can represent this by exactly half of this here. So, this is potential energy, therefore, this is you can say potential energy. What is this? This is total energy, right. So, please observe this is how you can remember as and when you look the graph, just remember by looking to this, remember kinetic energy is always positive, and by looking to this potential energy and total energy is negative, and also by knowing the values the total energy is half of the potential energy. So, you get this type of graph. So, you get this in objective type question. So, better go through the graph carefully. By looking to the graph you can assess the kinetic energy, potential energy and total energy. All the 3 energies are there in this graph. Hope you understood this one. So, very simple graph, but remember if you know these values directly you can remember this. So this completes the one total energy. This I said because as and when you come across any of the objective type questions, you expect this. So remember this graph. Okay, right. Now let me go for the next part, where in this chapter we come across the one satellites. Already we have learnt what is a satellite. Under satellite there are two types of satellites for the applications of satellites. So as and when you come across for applications, we have two types of satellites. So under that, the one we come across, the first one called as geostationary satellite, another called as polar satellites. These are the two satellites which we come across for the application of satellites. Is it clear? So please remember. So here in the earlier class we have learnt satellite. Also we have learnt the under the satellite we come across total energy of the satellite and also orbital velocity, all those things we have learnt. But today we are learning the applications of satellites. Under that we come across two satellites. One is called as geostationary satellite, another is called polar satellites. Okay, now let me just start that. I will just rub the board. This is types of satellites. Okay, under that the first one we come across geostationary satellite. Geostationary satellite. What was the second one? We come across second one called as polar satellites. So this is geostationary and that is polar. First let me tell you what is geostationary and let me go for the next one, polar satellites after this. Geo. Geo means earth. Stationary means which is at rest. So the one satellite which is stationary with respect to the earth is called as geostationary. So that is called as the geostationary satellite. So please remember, the first point I want to say is geo means earth. This is earth. Geo means earth. Stationary means it is at rest. So the one satellite which is at rest with respect to the earth, that is called as geostationary satellite. But remember, for this satellite we have the one condition. In this case satellite we come across, if this is the one, the earth, where we come across, this is said to be the equator. Let me say this is equator. Okay, this is equator. And remember here, the one satellite, always the earth will be revolving where it is always moving from west to east. So here we are placing the satellite on the earth, and where that satellite will be revolving around the earth. You already know, suppose if you want to say this is east, this will be the west, and this is north and this is south. This you know already very well. Now always our earth will be rotating from west to east. So I write the direction like this. West to east direction it will be moving, because this side is west, so it is moving around this direction. And here this satellite is revolving around, let me say this is one satellite we have here. This satellite is revolving around the earth. And where do we have the location of the satellite? Always at the axis of rotation. At the axis of rotation we can say the satellite will be placed, the one geostationary satellite. To place the satellite we have two conditions. We have to take the conditions, what is it? The height and one more time period. So you already have learnt in the last class, if the time period is for 24 hours and therefore the height will be 35,800 kilometer, but we take approximately equal to 36,000 kilometer. I said this one, when you calculate the one height, you get this, but approximately we take into 36,000 kilometer. So, for the geostationary satellite, always the satellite is located at the equator, slightly above the equator, nothing but at this position we are placing the satellites, and always that height of the satellite will be always it is placed at 36,000 kilometer. Whenever it is placed at 36,000 kilometer from the equator, and also the time period will be 24 hours. So, the location will be at the equator position at this point, and as and when it is rotating, it will be rotating around this. Okay. So, for the time period and also the height we have to take into consideration for this geostationary satellite. So, whenever you are placing this, it will be revolving around this, we said. Why did you say geostationary means? Let me say the time period is 24 hours, and we know the rotation of the earth is also 24 hours. So, the one satellite will be revolving around and it will be moving along the axis of rotation, due to which the time period is same and also the axis of rotation is also same, due to which the person who is standing on the earth will feel that satellite is at rest. He is able to say that it is stationary to him, because as the earth is rotating along the earth itself, satellite is revolving because the time period is same. Time period of the satellite is also same and time period of the earth rotation is also same, due to which the person feels that satellite is at rest. But the satellite will be revolving along the axis of rotation along with the earth, hence he feels that it is at rest. It is nothing but the geostationary, we say. How do you say this condition? Let me tell you for your convenience. By chance, if this is the one, you can say, let me say this is the earth. Earth will be always, it is nothing but elliptical orbit, you know. But here, if this is the earth, and this earth will be moving around from west to east. So, as and when it is moving means, let me say if it makes one rotation, if it moves with one rotation like this, then it will be moving with an angle of 90 degree. Suppose if it moves like this, it will be completing 180 degree. If it completes like this, it is nothing but 270. If it completes one complete axis of rotation, it has completed 360 degree. Okay. So, with the help of this, what we want to say here means that satellite will be in the satellite, that is nothing but when we are fixing the one antenna on the earth. When we fix the antenna on the earth, and that antenna, suppose if I am standing like this, the antenna is fixed along the one vertical direction, it is exactly top of the one person. Top of the one person means it is kept like this. As and when it completes the 1/4 of the cycle, nothing but if it completes 1/4 means it is completing the 190 degree. As and when it completes 90 degree, the axis of rotation, which is nothing but the one first earlier like this antenna was here. Why do we fix an antenna? To send the signals and to receive the signals from the antenna. We are prefixing the one antenna on the surface of the earth. So, as and when you are placing like this at the starting position, if once it is completing one rotation, it will be nothing but the 1/4 of the rotation, it will be moving like this. So, now again it feels it is vertically, it is the one top of the surface. When again if it moves like this, it will be vertically like this. Okay. Suppose the ones, if it is moving like this, it is situated like this, vertically like this direction. If it is again coming back here, it is again vertically top. So, what do you feel like this? As the earth is revolving, the antenna is also moving along, this means nothing but the antenna which is fixed, where it is in the one, it is sending signals or receiving signals, and due to which you get this is particularly used for communication purpose. This geostationary satellite is completely useful for the one communication purpose. Particularly, this geostationary satellite is also called as geosynchronous satellite. Geosynchronous synchronous satellite. Okay. By chance, if you are fixing a camera, that camera inside the satellite will be rotating along the axis of the rotation of the one earth, the satellite, due to which it will be taking the one photograph along the direction, in only one direction it will be taking the one photographs, the camera, okay, which is fixed in the one satellite, that is geostationary satellite. And because of this, it is particularly used for communication purpose, I said, communication purpose. So the use of this geostationary satellite is for communication purpose. In that, you particularly come across the one called as, the very particularly we say GPS, internets, and also you can say TV signals. You are just using the TV signals. So all these are particularly there with the help of this geostationary satellite. And in that, you can also name the particularly geostationary satellite, like earlier class I said some of the satellites. In that particularly, that is INSAT-1A, INSAT-1A, that is INSAT-1B, that is INSAT-1A and INSAT-1B, like this, particularly INSAT-1C, etc. like this. All these satellites are none other than called as geostationary satellite. What is the purpose of this satellite? The purpose of the satellite is particularly for communication purpose and also surveillance with respect to the communication, and also for the particularly for GPS, internet, TV signals. For all these, the one geostationary satellites are very useful. So therefore remember, particularly these geostationary satellites are used for this purpose, communication purpose. Okay. And also one more point I want to say here, the time period of satellite you already know in the last class, time period, where it is already you know the formula for this is, that is T is equal to 2 pi root of, that is r divided by, I have said here small r because this r represents the one nothing but called as, here it is like this. If the earth is like this, right, the from the center to the earth is nothing but this is capital R, and also we are placing the satellite at some positions, so that position we take it as h. So this is h, r plus h is nothing but called as small r, where we have taken as, that is small r is nothing but it is equal to r plus h. By using this condition, we can calculate the time period of the satellite. But remember here, this r is nothing but 6400 kilometer, where r is equal to 6400 kilometer. What is h? 36,000 kilometer. Using that, we will substitute for r. 2 is a number, pi is nothing but constant, it is 3.14. What is g? Capital G is nothing but called as, it is, you can take in terms of, that is 6.64 in 10 raised to minus 11. But if you want to write in terms of small g also you can use, to avoid this, the nothing but called as this condition, where I can say for gm I particularly use, you know the condition for small g is equal to gm by r square. Therefore I can write for gm also we can use gr square formula. At that time I can also rewrite the formula like this, where t is equal to 2 pi root of r cube means as it is, that is r plus h whole cube, gm means gr square. You already know r is nothing but the radius of the one earth, which is equal to 6400 kilometer. Small g, where small g is equal to 9.8, where let me write for the second one. Here only I will write, I will complete this first. So r is equal to 6400 kilometer, and this is h is equal to that is 36,000 kilometer and small g is equal to 9.8 meters per second square, and where pi is equal to 3.14. Using all this, if you substitute, you get the time period of the satellite, where this time period of the satellite is equal to 24 hours. This is what you get for time period. that is T is equal to, it is 24 hours. Okay. If you want to calculate what is the velocity of this satellite. So, when you want to calculate velocity, we are using the formula where velocity is equal to distance travelled divided by time taken. So, distance travelled, what is the distance travelled? It is completing one complete, that is rotation of the earth. So, you can say that is nothing but circumference of the earth, where circumference is represented by 2 pi r. At the same time, we are using the one T. What is T called as? Time period. So, when you take time period, you take the condition for one day, it is 24 hours. 24 hours means 24 into 60 into 60. So, at that time, let me calculate velocity is equal to circumference of the orbit divided by that is T, time taken. So, circumference means you can take it as 2 pi, here 2 pi r we have to take, that is small r, divided by capital T, but I rewrite this as 2 pi, that is r plus h divided by T. T is nothing but you take it as 24 hours. How do you write 24 hours? This 24 hours can be written as 24 into 60 into 60. So, if you substitute this using this, you get it is 3.1 kilometer per second. This is velocity of the satellite, where you can say geostationary satellite. It will be moving with a velocity of 3.1 kilometer per second, and the height which is of 36,000 kilometer and from the surface of the earth, and already you know radius of the earth is 6,400 kilometer. Using all this condition, you already know the geostationary satellite where time period is 24 hours, which is exactly equal to the one time period of the earth, and that is nothing but one rotation. So, due to which we feel the satellite is where it is rotating along the rotation of the earth, hence we feel the satellite is at rest, but it is not at rest, it will moving along the direction of the earth, hence we say it is geostationary satellite. It is moving around the rotation of the earth itself, but we feel it is stationary, but it is not stationary, it is moving along the direction. Hence, because of this condition, today we can say the most of the GPS signals, internets, TV signals, all are working with the help of this geostationary satellite. So, we can say this is particularly called as the one synchronous, geosynchronous satellite. You can also call it as one more called as, it is also called as communication satellite. You can also say it is also used for communication purpose, hence we call it as communication satellite. At the same time, it has a surveillance, where you can also say everything it matches with the one rotation of the earth, hence it is said to be called as the one geostationary satellite. At the same time, this only works along the direction of the earth, hence you can say the photograph will be taken along one direction, it will only be taking along one direction. This is what you can say geostationary satellite. Hope you understood. So, this is how you can remember for geostationary. One more we come across, the one called as polar satellites. So, there we can come across polar satellites. I will just tell you what it is. Let me rub this one. This second satellite, which is also called as the one called as polar satellites. This satellite name itself says, it explains about the poles. So, the polar satellites, the name itself explains, it is said to be called as polar satellite. How do you say this condition? Suppose this is the one earth, I said this is the earth which is moving from west to east direction, but our satellites will be moving around like this. Let me say this is north and south, and it will be moving like this. This is how the one satellite will be moving around this, like this. Poles to poles. It will be moving from poles to poles in this direction. Okay. This polar satellite is also called as the parking orbit, we say. We also sometimes for the objective type questions, you just remember it is also called as parking orbit. Okay. One more we call it as this polar satellites is particularly used to the one very important application. It is a very good satellite where it is particularly used for weather conditions, to explain the one applications of weather conditions. So, it is also called as, you can also call it as weather satellites. WEATHER, weather satellites. It explains about the weather conditions. So, particularly this is one you can observe, this weather satellite or parking orbit, also called as polar satellites. All these names are given to this, and it is very, very advantageous as compared to geostationary satellite. What is the reason behind this? Means these polar satellites are located slightly above the height where the height is very less, where earlier for geostationary satellite we are placing at some height, we said, that is 36,000 kilometer. But remember, this time period is very small. So, since time period is very small for this satellite, where you can say it is also called as low altitude satellites. It is also called as low altitude satellite. Because whenever time period is less means it is where you can say the height is very small. Low altitude, there the height was very large. High altitude satellites we also call for geostationary, but for this low altitude. What is the reason for low altitude? The height will be nearly 500 kilometer to 800 kilometer above the surface of the earth. So, it is very nearer to the surface of the earth, hence it you say call it as the low altitude satellites. And what is the time period for this is? It is time period is for this is 84 minutes. It is nothing but the time period is very less. You can say the time period is very small for this satellite, where it is nothing but it is the one satellite which is moving very close to the earth. So, we call it as low altitude satellite because it is very close to the earth, right. One more point, it is the the height will be very small, at the same time time period is also very small, 84 minutes. Slightly if you increase the height, slightly it may go for the time period slightly it may go for 2 hours, it may slightly if you increase it may go for 3 hours. That is how you can remember, slightly if you increase it. But remember at the same time it will be moving from north to south direction. What is advantages of this satellite means, particularly this is moving around north pole to south pole, and here in this satellite we can also fix a camera. That camera is more advantageous as compared to the one geostationary satellite. What is the reason in this case means, remember if this is our earth, if this is the one earth we have, and you know this is the one poles, north pole to south pole, and where we know this is our equators. But remember as and when the satellite is at this position, if you want to say, it will be moving like this with the one in this oblique direction, slightly in oblique direction, this satellite will be moving around the earth. What is the reason? Because earlier the satellite was at this position and it was taking the photograph from the satellite, that is nothing but already the one camera is fixed in it, due to which it will be taking photograph. By the time if it comes here, if it's slightly rotated, if it comes here, naturally the earth has been rotated slightly some distance. Because of this reason, whenever it comes here, slightly it will come like this. Suppose if it moves here, it will be moving like this. Slightly the one rotation will be like this, it will be coming like this in this case. So for example, if it completes one rotation, you get like this. If it completes one rotation, the second rotation you will get like this at this position. Second rotation, because it is moving from north to south. Third rotation, like this it will be moving like this. So like this it will be rotating around the earth by some oblique direction, because the one already the earth will be rotating, earth will be rotating. The camera which is fixed in the satellite is also taking the photograph. Whenever it is taking the photograph for some position, slightly the earth will be rotating, due to which it will be moving in the oblique direction like this. That is how the advantage you have. Because of this, it will take the one photograph all around the earth. It will not take the one photograph at fixed position, it will take all around the earth because of this condition, since it is moving from north to south direction. That is the one advantages of this polar satellite. Because of this advantage, you are ready to say here it can focus for the weather satellite, weather forecasting conditions, particularly the tsunami. When you want to explain about the tsunami, that condition can be explained by using this polar satellite. Suppose at some positions, if you want to speak about the one surveillance for the uranium deposits deep inside the earth, that photograph will be taken, due to which the one position, the exact position of the one uranium deposition, that can be explained by using these satellites. Similarly, agriculture, for the agriculture purpose, you can also use this, where you can say at what position the greenery is there, at what position there is a gray is there, due to which the agricultural surveillance can be done. Also, you can also survey for the mines, uranium depositions and petroleum depositions. All these can be explained by this one called as polar satellites. Similarly, you can also explain the one polar satellites will be explained for weather forecasting. So, the whatever the one rainfall forecast, the one weather forecasting, maybe the cyclone effect, all these will be explained easily by the help of this polar satellite, because it will be taking the photograph all around the earth. When once it rotates, it will be taking the one photograph of the complete around the earth, due to which all the conditions of the weather forecasting and all type of the conditions can be explained by using polar satellites. So, this is the one polar satellite where you are ready to say it is advantageous for us, where this job cannot be done by geostationary satellite. As compared to geostationary satellite, whatever the polar satellite does, that cannot be done by geostationary, because it is moving around the earth. If the earth is moving around this direction, if the antenna is fixed here, it will be fixed in the vertical direction. Suppose if it comes here, it will be fixed like this. So, it will be moving, it will be taking photograph only one direction, but this will be taking photograph if you rotate one rotation, it takes complete rotation of the earth. Hence, it is more advantageous. That job cannot be done by geostationary satellite, that can be done by polar satellites. This is how you can remember, and also you can take the one photograph of different conditions of all this, and remember, particularly 84 minutes I said, nearly you can also say, which is approximately equal to 100 minutes you can take. By using this, you are ready to say this, the time period is very small, and also the one height is also very small. So, you are ready to say it is low altitude satellite, and it also parking orbit. So, it can park at different positions and it will take the one photographs, due to which it is called as parking orbit. And also it is, since it is moving around poles to poles, it is called polar satellites. So, this is how you can remember these conditions, you just remember, and also advantages compared to geostationary. So, most of the one weather forecasting, tsunami and uranium deposits, mines, deep forest, surveillance of agriculture, and all these will be, and for the one military purpose, for all these the one it is useful for spy purpose, particularly we go for the one polar satellites. This is how this completes the one called as the nothing but called as types of satellites. Okay. Now at the same time, in this chapter we come across the last part of this, we call it as weightlessness. That part is left out in this. So let me explain the weightlessness, which is very simple. So weightlessness. What do you mean by this? The pull exerted by the earth on the body is called as weightlessness. You can say pull exerted by the earth on the body is called weightlessness. This weightlessness you can observe particularly in space shuttles, that you observe in the space shuttles. On the earth, where do we come across? As and when you move inside the lift, you observe the weightlessness. Because a person, whenever he is moving, when he is pressing the foot on the floor, the reaction force will be acting on this, due to which as and when the reaction force is acting on him, hence the one upward force will be there and downward reaction force is acting on that, hence he feels weightlessness. So as and when you move inside the lift, he moves inside the lift means when he is going downward. So naturally he is accelerating downward. The person will be accelerating downward. So when suppose if the lift falls freely, suppose the lift is moving downward direction, the person is also moving inside the lift in the downward direction. He is accelerating downwards, we can say. By chance, if it falls freely, at that time you can say, if the lift falls freely, the person feels weightlessness. He feels weightlessness. For this you can say, very simple point, what happens here in this case means, so the gravitational force of attraction between the earth and the person who is inside the space shuttle. So that is nothing but, first let us take with respect to satellites. So satellite, of the mass of the satellite is small m, let me take, and mass of the earth is capital M, and always remember the g acceleration due to gravity, that is nothing but gravitational constant is acting on that. So at that time you can say this is the earth, if satellite is at this position, exactly from here to here the one, it is the radius of the earth, capital R. Here let me say this is mass of the earth, this is small m. What is this m? This is nothing but satellite mass. So here what happens here, there is a force of attraction between the mass of the earth and also the satellite, and since they are separated by some distance, naturally there exists a force of attraction between them, there arises the one gravitational force. At that time we say, where F is equal to capital G, capital M, small m divided by, that is nothing but R square. This is the one, the gravitational force of attraction will be acting on this. For example, if this satellite is at some height, if it is exactly at some height means at this position, if it is there, we take into condition this is h. At that time I take small r is equal to r plus h. At that time I take the condition as where it is r square. At this time I take the condition from here to here, the one distance from here to here is nothing but which is r, because this is h, this is r, where you can take the one gravitational force of attraction is F. And since the satellite is always looking towards the center, there exhibits a centripetal force, where we call it as mv square by r. But remember, this is called as orbital velocity, and whenever there exists an this force and this force both will be having the one equivalence. At that time we say, then you can say this G capital M by R square minus, that is nothing but equal to M V naught square by R. At that time this R and R gets cancelled, this M and M gets cancelled, where you can say Gm by R is equal to V naught square. This is what we have the expression for the one whenever it's a gravitational force of attraction between this and this. But at the same time, if I want to say a person is there inside the satellite, if the one satellite where a person is there, astronaut, he will be there, his mass is m dash, and that mass will be acting on him, that is nothing but the gravitational force is acting on that, due to which where you can say the one gravitational force will be acting on him means at that time I take where F is equal to capital G capital M dash by this is R. This is the one force will be acting on this. At the same time there exists a reaction force which is represented by R. That, and hence whenever there is a reaction force acting on this, at that time where you can say that he feels weightlessness, because the person is inside the satellite, due to which reaction force is acting on him. Therefore you can say where it is nothing but Gmm by R, that is G m dash m by R minus R, which is the reaction force which is acting on him. And hence equating this you get, that is nothing but the one finally the Gmm dash by R, and one more, that is nothing but here mv square by R, this will be acting on him, and hence he feel weightlessness inside the satellite. So you can say here at that position, that is v square by R m dash nothing but v square by R m dash minus, it is nothing but called as minus R is equal to m v square by R, where you can say here this is nothing but where this, if you take this side, then naturally v square by R m dash minus, that is this will come this side, minus m v square by R, where the person who is inside the satellite will have mass m dash, and that is equal to R. Since this will be cancelling here, therefore R becomes 0. So the reaction force inside the satellite field, it is equal to 0. Hence the person who is inside the satellite, where you can say W is equal to mg, nothing but where W is equal to R. So the reaction force is acting on him, where R is equal to mg. This G inside the satellite, whenever this reaction force is 0 means nothing but this is equal to 0. So a person feels weightlessness. So naturally you can say a person feels weightlessness. So this you can observe inside the space shuttle. By chance if you are observing this on the earth, as and when the lift is moving downwards, then you say it is nothing but accelerating downwards. So the lift is moving downwards, it is accelerating downwards. By chance if the one lift falls freely, the person inside the one lift feels weightlessness. This is how you can observe the weightlessness on the surface of the earth whenever the weight will fall, that is lift falls freely, right. So this completes the one gravitation chapter. Maximum concepts we have completed here based on all the things which we come across in this chapter. So in the next class, let me go for the problems using NCERT textbooks. Okay, let me solve the problems in the next class. This completes the one gravitation chapter. Hope you understood all the things. Please practice it very carefully. It is very easy if you learn the things correctly. And also the one scoring chapter, it is very important chapter. Okay, hope you understood all the things. Thank you.